Okay, so if you've plotted it correctly, your first point should be back 3 and up 7. Because it's -1 squared minus 2. -1 squared is positive 1. This is the rule. I've got to use this rule.
And you say minus 1 it goes up to 6.
Okay, the next
How
point
is
is at
7
minus
7?
2.
Doesn't it mean 7 should be 5 then?
Then at -1 minus 1. Now, if you join that with a smooth curve, no bumpy bits, it's got to be beautiful and smooth.
Oh, smooth like a baby.
Then you create a parabola. That looks like that. So that is y equals x squared minus 2. So what happened between... So my original parabola, Bailey, my original parabola went through the origin. Did you see that?
The origin.
And this was the y equals x squared. Can you see this parabola? What's happened to this one?
It does the same thing.
It's the same shape.
It is.
Where does it go down to?
It goes up to -1, -2.
Goes down to -2. So my parabola, it's the same shape, that same beautiful curve. It's just moved down by 2. What do you think would happen if my rule was y equals x squared plus 2? It would have moved up 2. Okay? Alright, we ready to go on to the next type of graph?
Yeah.
Okay, do you want us to film this section again?
Yes.
Are you already filming, are we?
Yeah.
Okay, the next section. Shh. Bella. What's wrong, Callum?
Is x up and down and y is across?
No, x is across. Okay?
X equals cross.
And y is up and down.
Yes. Because the calorie goes x across.
Okay, our next non-linear graph. Shh. Our next one is a cubic. Now, a cubic is an equation with a cubed in it. So our most basic equation will be y equals x cubed. I want you to draw another table of values from -3 to 3. See if you can work out the shape before I get it on the board. Okay? So let's see what a cubic looks like.
After this, I'm going to get a drink.
Using the same thing.
Why don't you answer the question?
No, you're not getting a drink.
Well, then you're going to answer it then.
Alright, let's make it a little bit different. Let's do -2. -1, 1.5, 0, 1.
What am I doing here?
Shh. Jane.
Wait, what?
If we've already started with the negative,
That's fine. Right, put a half in it.
You say it.
Alright, so if I put -2 into this rule, what do I get? Matthew. If I put -2 in the rule, what's -2 cubed?
6.
+6?
Negative
2 times -2 is 4 times -2.
negative 8.
-8.
That's what I said. Well, I said 8.
Okay, it's -8. What do you think -1 cubed is?
Negative 1.
1.
Negative 1.
1.
Yeah, negative 1.
You
You just look so
No,
confused.
you look at your answer was the wrong.
Okay, -1/2. What's that cubed?
Negative half.
How do you know what
Almost.
-0.25.
Negative 1. What's 0 cubed?
0.
What's a half cubed?
1 8. 1 8.
1 8.
1 8. 1 8.
What's 1 cubed?
0.125.
What's 2 cubed?
Something.
So 8.
Okay, so let's put another set of axes in.
Or drag it drop.
Okay, so on my axes, which one's this? Is it x or y, Callum?
Y. X is across.
X is across and this is y.
X cross.
So my first point is -2, -8. Now I left -3 off because that gave me -27 and I do not want to draw -27 on that. Okay? So at -2, I've gone to -8. Oops. 1, 2, 3, 4, 5,
6, 7, 8.
8. At -1, I'm at -1. At -1/2, I'm at -1/8. So I'm almost there. Right at 0, 1/8, 1 and 8. 2, 4, 6, 8. So it's kind of a bit hard to see.
It is.
Okay. It's quite hard to see what's going on, but can you see I'm coming up? But I asked you to include this to see that it's actually curving round and then it's curving out again. So it comes up here, it curves round, and then it curves back up. Okay? Can you see it's much steeper than the parabola? The parabola was a bit wider. But because it's a cubed, it's actually getting very small or very big, Matthew, quite quickly. So my next value, I'm at 27. Okay, and then at 4, what am I at 4? What's 4 cubed? Anyone know that? 4 times 4 is 32. 16. 16 times 4 is?
I don't know my
48. 64. Very, very high. 64. So it's going up very fast. 64. Okay? It's just almost on the line there. Okay? So it's almost on the line, not quite. It shows the shape there. Okay? Alright, let's do one more curve. Shh. Charlie, I don't want to see the back of your head. Matthew, do the right thing. Okay, let's look at what happens. Let's be really tricky. This one's called an exponential. What happens with this one? I'm going to put the x in the power. Shh. Let's try this one. The x is in the power. So it's a bit different. So I'm going to put it to the power.
That's pretty funny.
You might want to use your calculator if you want. Okay, so we'll do -2, -1, 0, 1, 2. So if I do 2 to the power of -2, Matthew, calm down. 2 to the power of -2. Grab a calculator. You don't have to do it in your head. 2 to the power of -2. You get a little tiny decimal. 0.25. Shh. If I do 2 to the power of -1, what do I get? 2 to the power of -1. 0.5. So it's a little bit bigger, isn't it? What's 2 to the power of 0? 1, because anything to the power of 0 is 1. What's 2 to the power of 1 mean? 2 to the power of 1? 2. 2 to the power of 1 is just 2. What's 2 to the power of 2? 4. Let's add one more. What is 2 to the power of 3? Careful. 2 to the power of 3. 8. 8, because it's cubed. Alright, let's draw another picture. Okay, what's the problem, Callum?
I don't get
Don't understand what we're doing?
I know this bit, how I don't know how you find x though. Or will
Are
they
they-
always be given to us?
You choose them. Okay, so we're choosing something to give us a lot of detail so we know what's happening.
Yeah, but I also don't get the explanation when we do that.
Okay, so let's look carefully at these points when we go across. Now, first of all, this is x, isn't it?
Yeah.
Okay, and this one's y. So my first point says x is -2 and y is 0.25. So I go to my x-axis, I go to -2, so that's back 2. Then from there, I'm only allowed to go up 0.25. So I'm only going up a tiny little bit, okay, just a quarter of the way up, a little dot there. Okay? Does that make sense? This one says I've gone to -1, then I've gone up a half. So I'm going back to -1, up to a half. It's a bit off, but anyway. This one is at 0, 1, so be careful with this. This means I haven't gone across, but I've gone up 1. This one means I've gone across 2, sorry, across 1, up 2. Does that make sense?
Yeah.
So I've gone across 1, up 2. then across 2 up 4, and then across 3 up 8. So can you see where all my points are coming from? Each of these pairs gives me a unique spot on the graph. This is a bit of a weird looking graph. So it's clearly going up and up over here.
It looks like sale rates.
What's happening over here? So I've got a half, I've got a quarter. The next one would actually be an 8,
Then we go back up again.
then a 16. Do you think it's ever going to go back up again? Let's try. What happens if I put 1,000 there? Okay, so I went 1,000 that way. Try on your calculator. What's 2 to the power of negative 1,000? What's that going to be? See what your calculator says.
0.
It's getting closer and closer to 0. It doesn't actually go back up again. And it doesn't keep going down and down. We've discovered something that is kind of cool. Our graph, no matter how far I go across, never ends up negative. And it never ends up going up. This has got a special name. This is called an asymptote. Okay? Asymptote. I've been doing maths for a while now, Charlie. I learned lots of big words.
So much.
Okay, an asymptote is a line that you never ever reach. Okay? You get closer and closer, but no matter how far you go, you never actually reach that line. You certainly never touch the line. Okay, so you never touch the x-axis. It never hits the x-axis. There is never an x-intercept. Kind of cool. Alright, so this graph goes along
So it just gets
almost
smaller
to
and smaller
0,
and
but never touches. And then it shoots up to infinity over this side.
Also,
Kind of cool.
for that one, do we start on the very
It basically keeps going, but it cannot touch. Okay,
Yeah, like-
it does not touch.
But when we do the line thing, do we start where you started?
Yeah,
Because I started with the first one.
that's fine. Shh. Okay, Gerhard just asked a good question. Do I start from my first dot? What I would always recommend is you use your dots to get the shape, but your graph should always extend to the edges of this box. So even though my dot's here, I will always extend it up here. Even though my last dot's here, I'll always extend it to the edges of the box that my graph is in. Okay? Because I know that the graph goes on forever. Okay? So that's an exponential. Exponentials are quite unusual. In one direction, they'll hit an asymptote, a line they don't cross, and the other direction, they'll go to infinity. Shh. Yep.
In our exam, would it say what is an asymptote?
No, it's just going to ask you to basically plug some numbers in and draw a shape. Okay? You don't have to memorize these at a year 8 level, Charlie. You don't have to memorize the names of these. You don't have to memorize what they look like. You just have to be able to take the graph that I've given you, the equation, and be able to create the picture. Okay? You don't necessarily have to memorize what they look like without doing the table of values. We will work on that later, but not in year 8. Okay? Last shape, very last one. I'm just telling you the names just to, for sake of interest. Okay, we met the parabola. The last one is a hyperbola. Okay? Now these ones have x's on the denominator. So my equation we're going to start with is y equals 1 on x. Okay? Y equals 1 on x. Hyperbola. Now, this is an unusual graph, so I'm going to ask you to find some more points because we need more detail to be able to draw this one in. It's a bit of an unusual graph. So we're going to have quite a large table of values. Okay, so we're going to do -3, -2, -1, -1/2, -1/4, 0, 1/4, 1/2, 1, 2, 3. I know it's a really big table of values, so it's a bit of an unusual graph. So I want you to see what it looks like. So if I had... So if I put -3 in there, 1 on -3 is just -1/3. Are we happy with that? Does that make sense, Callum? So if I put negative 3 in here, it's negative 1/3. Okay? If I put negative 2 in here, Charlie,
Negative half.
negative 1/2. If I put negative 1 in here,
Just one. Negative one.
negative 1, well done. What if I put negative 1/2 in there? What's 1 on negative 1/2? You can use your calculator if you want.
1.5.
Don't just guess.
I don't know how to type that into the calculator.
Negative 2. So on your calculator, you put the fraction, and then, so I'll show you on the calculator. Okay, so I could put in here. So this is my fraction. On the top I have 1. On the denominator I want another fraction. I want to put negative 1/2 there. So I can press the fraction button again. And put negative 1/2 here.
Whoa.
So I've got 1 over negative 1/2, which is negative 2. So you understand how you would type that in, Lawrence? In your chair, please. So that's negative 2. When I put negative 1/4 in, I get negative 4. When I put 0 in, what happens? What's 1 divided by 0?
0.
Really?
1.
Minus 1.
0. 0.
Try it on your calculator, what happens?
It's just 0.
It's an error. It's not possible. You cannot divide by 0. How many zeros go into 1?
Zero.
Infinite. Okay? 0 is nothing. It just doesn't work. Okay? There is no value that works when x is 0. So if nothing works when x is 0, then I have no what?
What?
No y-intercept. Yeah, because it doesn't exist. No y-intercept.
Yeah.
So I can't have x equals 0, can't have a y-intercept.
Good vocab.
Alright, so I'm just going to finish this for you. 4, 2, 1, a half. Okay, last one. So I'm going to plot that now. Bring another one of these over. Okay.
No!
Shh. Boys, stay focused, please. Last one. Okay, -3 minus 1/3. So Callum, which one's this one? X or Y?
X.
X. And that's Y. So I'm going to -3 along here, but I'm only going up 1/3. So tiny little bit, sorry, I'm not going up 1/3, am I? I'm going down 1/3. So I'm down here. At -2, I'm at -1/2. At -1, I'm at -1. At -1/2, I'm at -2. At -1/4, I'm at -4. That's kind of a bit weird. We've got these little dots going around the corner there.
How do you... Well, that doesn't use it. It says -1/4.
-1/4, so almost on the y-axis. I'm down at -4. Over here, I cannot have something that gets 0. Nothing happens at 0.
Yeah.
Charlie, focus. At 1/4, so just a little bit over here, I'm all the way up at 4. So I've gone from down here to all the way up here. So we're going to deal with that in a minute. That's a bit weird. At 1/2, I'm at 2. We're going to see what happened there. At 2, I'm at 1/2. Okay, so I've kind of got some down here, and then all of a sudden I jump up here. Let's try, what if I'm even close to the y-axis? What if I had -1 on 1,000? If I had -1 on 1,000, and I put that in my equation, I actually get -1,000. So I'm way, way, way down here. But then if I put in +1 on 1,000, I end up at 1,000, which is way, way, way up here. What we've discovered is that this graph is not continuous. You cannot go from all the way down here and all the way up there without taking your pen off. So this is the first graph that we've created that is not continuous, which means I can't draw it in one line. I actually have 2 lines that make up this graph. Okay? And this is also an asymptote. I never actually hit the line in the middle. I go very, very close to it down here. I take my pen off. I jump up here, and I come very, very close to it here. So it's two parts. Yep.
If there was a zero there, they'll be connected with it.
Yes, but there's no zero, does exist. Now also when I come up here, this is another asymptote. So this is kind of a weird graph. I have this curve here, and over here I have another curve. So I have two asymptotes. And that's the last shape. We're done, Olga. Can you press up?